Hello guys, this is Dr. Hayek, and today we will talk about conformations of cycloalkanes. Some students might be thinking that cyclopropane has a triangular shape, and cyclobutane looks like a square, cyclohexane looks like a hexagon. However, none of these shapes are the exact shapes that cyclopropane and cyclobutane and cyclohexane take in nature. What is the reason? Now, we have discussed previously that sp3 carbons, they have a tetrahedral conformation, which means that the angle between every two bonds is equal to 109.5 degrees. So looking at the triangle, the angle here, it's equal to 60 degrees. And the angle in a square, it's equal to 90 degrees. And in a hexagon, the angle is equal to 120 degrees. So none of these shapes gives an angle that is equal or close to 109.5. Therefore, these shapes, they will be affected by a strain which is called the angular strain. The angular strain will decrease the stability of these shapes, and therefore these will not be the lowest energetic shapes. In reality, cyclohexane adopts a puckered conformation, which is more stable than any other possible conformation, and this puckered conformation, it's what we call the chair conformation. The chair conformation is so stable because it eliminates angle strain. All carbon-carbon angle, any angle you pick from here, it's equal to 109.5 degrees. When we draw a chair conformation, we need to make sure that we are able to identify the types of carbons that we have on this conformation. So the carbons that we have on this conformation, we have the down carbons, and which are 3. So that's down carbons, we will assign it by an empty circle. So we have this one and this one and this one. And the up carbons, we will assign or designate them using filled circle. So here you go, we have an alternation between up, down, up, down, up, and down. Why it's important to designate or to determine the up carbons and the down carbons? This would help us to draw or determine the direction of the bonds. For the bonds, we have two types of bonds. We have axial and equatorial bonds. Now for axial bonds, on the up carbons, the axial bonds are facing up. So then we will draw them. 3. Axial bonds are vertical bonds. So on the up carbons, they will be facing up. On the down carbons, they will be facing down, as you can see it in here. Now, equatorial bonds, however, on up carbons, they will be facing down. So I will just draw the equatorial bonds, and they will be facing up on the down carbons. So drawing these bonds is very important when you draw a chair conformation. So the red ones are the axial and the blue ones are the equatorial bonds.